All right, there's going to be a video for each of the odd problems on here explaining how to go through these. We are almost guaranteed to see a problem similar to something in this packet on the AP exam. And it's usually somewhere around question 5 or 6, but that part's not really important. So hopefully as you go through these, you'll see a lot of commonalities and similar types of questions. So this one says Taylor series for a function f about x equals 1, there's the center, is given by this series. We can also see the center is 1 from here, and converges to f of x for anytime x minus 1 is less than r. R is the radius of convergence. Find the value of r. So how do we find a radius of convergence? We usually use ratio test and start working on this, not finding the whole interval, but work on this until you can see the radius. So start with ratio test. Limit as n approaches infinity of the absolute value, so we ignore the -1 part for now, of the n plus 1th term, 2 to the n plus 1, times x minus 1 to the n plus 1, all over n plus 1, divided by the nth term. Instead of having a complex fraction, we multiply by n over 2 to the n times x minus 1 to the n. Don't drop your limit notation until you actually take the limit, and you really should rewrite this simplified. Don't just start slashing things out. So we want our work to be clear and easy to follow for whoever's grading the AP test. So 2 to the n plus 1 over 2 to the n is 2. X minus 1 to the n plus 1 over x minus 1 to the n is x minus 1. There's still an n, and there's still an n plus 1. So now I can take the limit of this. Remember, you're just putting infinity in for n. So we have a horizontal asymptote here. N over n plus 1 is 1. So we would be left with the absolute value of 2 times x minus 2. Now, this expression converges by the ratio test if 2 times x minus 1. Sorry, I'll get my pen to work again. I miswrote this center right here. If 2 times x minus 1 stays between -1 and 1. Now remember, you're not finding the whole interval. Don't waste your time with that. They just want the value of r. So you can see the value of r as soon as you isolate the x minus c. So I need to divide by 2, which puts x minus 1 in between plus and minus 1/2. So this shows me that the radius of convergence is equal to 1/2. Because I don't know about the endpoints, whether to include them or not, but the distance from the center to each endpoint is 1/2. All right. So that's it for part A. For part B, find the first 3 non-zero terms and the general term of the Taylor series for f prime. So remember, this is f, which is the derivative of f about x equals 1. So when they tell me to write terms, instead of coming up with the series right away, because we've taken derivatives of series, start by, if you just have to do terms, start by generating terms and then taking derivatives of that. That's usually easier, less work to do. You don't want to write the series and then plug in n's to get the first 3 terms. So I'm going to do this. F of x is equal to, start plugging in terms. So this says to start at 1. So -1 to the second is +1. Then this will be 2 to the first over 1 times x minus 1 to the first power. We need 3 non-zero terms for f prime. So I'm going to take this out to 3 non-zero terms here. Okay, so plug in 2. If we plug in 2, we get -1 to the third. So minus 2 squared is 4 times x minus 1 to the second over 2. I don't care too much about simplifying this yet. I can in a minute. And then, get this to fit. And then the next term is going to be plus. We're plugging in 1, 2. Now we're plugging in 3. So 2 to the third is 8 over 3 times x minus 1 to the third plus ... plus. General term is right here, -1 to the n plus 1, 2 to the n x minus 1 to the n over n plus dot, dot, dot. So here's f of x. We're supposed to find the first three non-zero terms of f prime and the nth term, the general term for f prime. So all I have to do is take derivatives of each of these terms. So the derivative of 2 times x minus 1 is just 2. You can simplify this if you want to. This was 2, or I'm going to pull the 2 down. So the 2's are going to cancel. So I'm going to get minus 4 times x minus 1. So the only benefit of simplifying f of x is so that you don't mess up somewhere on your f prime if you're simplifying. If I pull the 3 down, the 3's are going to cancel. So I'm going to get plus 8 times x minus 1 squared. So here are the first three non-zero terms, plus dot, 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 plus. Now use the same math on the nth term. So when you pull the n down, the n's are going to cancel. You'll still have this negative 1 to the n plus 1. You'll still have 2 to the n. You'll have x minus 1 to the n minus 1, and there won't be an n in the denominator to cancel. Now remember, for the AP exam, you don't have to simplify these terms, so you could still have made this 4 times 2 over 2 times x minus 1, or you could have left the n over n there. I think it's good practice to simplify a little bit, just so you can kind of see better what's going on, and if you have to use these functions for anything else, it's nice to have a simplified form. But at the same time, you don't want to screw up something silly simplifying and then not get credit. So it's up to you. Think about your math skills. Taylor series for f prime about x equals 1 found in part B is geometric. So if we're told we have a geometric series, remember that means we can find the sum if we know the first term and we know the r, which we do. Find a function f prime. So find this for f prime for which the series converges on the interval we were given. Use this function to determine f for this same interval. So find f prime and then turn around and find f. So let's start one at a time here. So find f prime. We have the Taylor series for f prime. This is geometric. So the geometric equation, the Taylor series, should add up to a over 1 minus r. A is the first term, 2. R is what you get when you divide consecutive terms, and you don't need to check a bunch of consecutive terms. We're told this is geometric, so just divide the second term, including its negative sign, by the first term, and you get negative 2x minus 1. So 1 minus r is going to be 1 plus 2 times x minus 1. So this is f of x, because f prime of x, excuse me, because the series, the geometric series for f prime has this sum. Remember, we did that in the beginning of the chapter. Find the sum of the geometric series. So I'm going to clean this up a bit, though. I'm going to say, okay, so f prime is 2 over, if I distribute the 2 through, 2x minus 2 plus 1 is 2x minus 1. So here's f prime. Now we are supposed to use f prime to find f. So what's the relationship between f and f prime? Well, f of x is equal to the integral of f prime of x dx. And remember, they want the function. They don't want the series. They want the function. So don't use a series and integrate. We're going to say that means we're supposed to take the integral of 2 over 2x minus 1 dx. So back to like a chapter 4 question, integrate this thing. All right, so if I integrate, I need to use a little bit of u sub. U is 2x minus 1. Du dx is 2. So du is 2 dx, which we have. So this is really just the integral of 1 over u du. So no extra adjustments needed. The integral of 1 over u is natural log of the absolute value of u, and then we put it back in our 2x minus 1 expression. Remember, this is an indefinite integral, so you have plus c. Now we're not finished. We need to find what c is. Okay, so how do we do that? Well, plug in the center. So f of 1, you always plug in the center because that's the one point that you know about, should equal the natural log of, plug in 1 here, natural log of, not natural log of 0, natural log of 1 plus c. The natural log of 1 is 0, what is f of 1? So f of 1 comes from the Taylor polynomial, remember? So let's go back and look. Here's the series for f of x. The first term you get should be the value of f of c, right? F of c plus f prime of c times x minus 1, blah, blah, blah. So let's go back and look. Somewhere I generated, here we go. So somewhere I generated what this term was. What is f of 1? Well, f of 1, when we plugged that in, we got 2 times x minus 1. So 2 times x minus 1 is 1 minus 1. So c comes out to be 0. C is pretty often 0 in this case. If you forget to do this and you just write ln of 2x plus 1, I'm not sure, based on scoring guidelines, if you would get a separate point for showing how you found c or not, but it's good practice to do. So this tells me that finally f of x is equal to the natural log of the absolute value of 2x minus 1. So again, you can find the function value by evaluating at the center, because remember, the power series and the actual function itself, whatever f of x is, which we didn't know until this point, they're equal to each other at the center. So that first term, that constant term, comes out to be the value of the function. Okay, I think that was everything we had to do for this problem. So that's our first problem, all finished.